Okay, experiment 9.1 on your page 245. Studying impact forces. And in this experiment, we want to investigate the impact forces during the collision. Try to look at the name of the apparatus. The first one is the trolley. On it, we will have a force sensor. This sensor will record the force during the impact when this collides with metal cylinder. And also we have the other computer device, data logger interface, and then link up to the computer. And also we have the other sensor, motion sensor, to record the speed of the trolley. Okay.
Studying impact forces by data logging. To study the impact force of a trolley, a motion sensor and a force sensor connected to a data logger are used. The track is tuned at an angle to the horizontal. Start data logging. Release the trolley. The trolley runs down the track and eventually collides with a heavy metal target. Obtain a velocity time graph and a force time graph for the motion of the trolley. Find the velocities of the trolley just before and after the collision from the velocity time graph. Hence, find the momentum change of the trolley during the collision. Find the area under the force time graph. Compare it with the momentum change of the trolley.
Okay, in this experiment, you
Go
can
to
find
the horizontal.
This.
At an angle to the horizontal.
Okay, you can see that the one way will have an angle, inclined angle, but wide. Okay, in the last chapter, you should know that friction compensated one way. Actually, this one is a friction compensated one way. We know that we have the friction, but we use the component mg sine theta of the weight to balance the friction to eliminate the effect of friction. Then this one way we will call it friction compensated one way. This one to make we haven't any the other forces acting on the car. Now keep going. The procedure, you can look at the video. You can find that we want to get the VT graph using the motion sensor. We also want to have a FT graph, use the force sensor. This one is the discussion. How can we determine the impact time? You can look at the graph. The graph will be like that. You can see that jump up and down. How to find out the impact time should be measure the time interval between it. This one will be the impact time. Of course, the x-axis will be the t. If this one is the force time graph, then this one will be the maximum impact force. Okay, go back to here. The diagram will be like that. This one, force time graph, actually we have two different type of them. In the wheel experiment, we can have the left hand side. It means that this one. In this graph, you can see that the force is changing. It's not the same. We have the maximum force acting on it. This one is the impact time. But mathematically, this one very difficult to see it, except we use the data logging. In examination, sometimes maybe like that. We will think that the F FH force. We assume that during the motion, the force is keep constant, like that. But how to find out this FH force? You can use the same method. In the last session, we know that force time graph, area under the graph. What is the meaning of it? Do you remember it? This one should be F times T, should be delta P, momentum change. This one, the force is changing, but we also have the area under the graph. This area should be the same as it, equal area. Okay, they have the same impact time. Then using the calculation, if we know that this area, we know that, it means that this area, you also know that, time, you know it, then you can calculate the FH force. Okay. Example 5. Okay, example 5, collision test. Look at this diagram, FT graph. Okay, and the mass given to you using the force sensor to get this graph. Given that the area under the graph is 0.65 Newton S, it means that this part area given to you. And then find out the maximum impact force. Look at this. This one is the force. During the collision, the force, we will say that impact force. Then you just need to find out what is this value. Read it from the graph. Should be 14.4 Newton. This one is the maximum impact force during the motion. Once again, this one, where is it or when is it, will be the middle time of it. For example, if this one is a ball, just only touch it, it means that this one 1.5. Leave, okay, leave the wall will be 1.6. And then how about 1.55? 1.55 will be maybe like that. Okay, the deformation will be the greatest, and also this ball, you will stop here. During this motion, during this time, the ball should be moving in right hand side. During this time, the ball should move in left hand side. At this case, should be momentum at rest. Okay, 變形變得最勁，扁晒 will be here. Then at that time, the force will be the maximum, the peak value. Part B, find the average impact force. Because we know that the area, we also know that the impact time. Then this one is the impact time. Then we can know that area under the graph should be change in momentum, should be 0.65. The question is given to you. Average net force should be change in momentum over the time, 6.5. Part C, find the speed of the trolley just before collision. We know that change in momentum is this. Okay, change in momentum is 0.65. Finally, stop here, and initial momentum should be 0.2 U. After the calculation, you can find that U should be 3.25. How about this? How does the shape of the graph change if we have a spongy? You should know that what's a spongy. It will absorb the impact force. But how? Increase the impact time, because it is very easy to have deformation. Then the maximum impact force will be smaller than before. The peak value will be lower one. But the area under the graph should remain unchanged. The graph will be like that. Okay, the time for it will be longer one. But look at this. I think that the red one is some mistake in this case. Okay, I suggest you don't use this, because we will think that the impact time, the time for it to have collision should be starting from 0.1, because there is no change in U. They should have the same time. Then the red one should be extended to here, like that. So the same starting time 1.5, but using the spongy, the time will be longer. The peak value will be shorter. This one is the correct one. This one is wrong one. And also I want to go back to here, this diagram. Okay, we know that the area, we know that this. Actually, we can find out the FH force. The FH force after the calculation should be 6.5, around here, like that. This one tells us that this area is also 0.65 Newton second. Okay, next one. Colliding with hard and soft object. Hard object, very difficult to have deformation. It means that the impact time will be shorter than before. Shorter one, but the initial case, the object U will not be changed. It means that initial momentum will not be changed. After to collide with the object, maybe finally stop, then the total momentum change will not be the same. Will be the same. Okay, then the area under FT graph will be the same. But if this one, if the impact time is shorter impact time, but the area should be the same, then the FH value will be increased in this way. This part shorter one, then the height will be higher one. FH1 is this, the peak value is also increasing. But if we use soft object, very easy to have deformation, then the impact time will be longer than before. The area should be the same. Then the height, it means that the FH force should be lower than before. Peak value also.